Hello. Only 4 students. It's me again, guys. The second part is from 11 till 12:40. Again, quadratics. May I see who are here? Can you please write me? Hello, hello, hello. Dimitar en spase, where are ye? Sandra? I'm sorry, guys. I'm checking my students. Today, Strumitsa kids are lazy. Giovanna, Blerta, Damian. Okay, while we are waiting for the others, let's read the question. Yane, this is wrong one. This is for second graders. Yesterday, Miss Sevgi had lesson from my account. Now you have lesson with Mr. Atayane. This lesson is for second graders. Okay. X squared plus px plus q and x squared plus qx plus p, I forgot, is 0 here, are given. Two quadratic equations are given. If p and q are two different positive integers, for how many ordered pairs p and q the equations have no real roots? No real roots. How to solve the problem? What do you think? Two equations are given. Again, p and q. We cannot get rid of p and q. P and q are two different positive integers. It's important, positive integers. And for how many ordered pairs p and q, these two equations have no real roots. If an equation has no real roots, then yeah, with discriminants, yeah, you're right, Philip. Delta 1 and delta 2. Both delta, for both equations, deltas will be smaller than 0. So you need to find delta for both equations. What is delta for the first one? What is delta for the second one? Check them and then you will find the ordered pairs, possible ordered pairs, where delta 1 and delta 2 are smaller than 0. What happened to the others? Did they go to have a breakfast? We were 19 in the previous lesson. Just 10 now. Okay, P and Q, you say P and Q are supposed to be smaller than 4. It is true. And since we know that P and Q are different numbers, assume that one of them is smaller than the other. Assume P is smaller than Q. Then write all possibilities. Damian, what do you mean? 11? Can I start to solve the problem? No reaction? Okay. Okay. First, I got delta for both equations. Delta 1 is the discriminant for the first equation will be p squared minus 4q. Discriminant for the second equation will be q squared minus 4p. From here, if we know that both equations have no real roots, then they are both, delta 1 and delta 2, they are both smaller than 0, which means that p squared minus 4q is smaller than 0 and q squared minus 4p is smaller than 0. Let me focus on the first one first. The first delta. If p squared is smaller than 4q, can I square both sides of the equation? I can. So it will be p to the power of 4 smaller than 4q to the power of 2, which is 16q squared. Then let me check the second one. Q squared minus 4p. If it's smaller than 0, then we can say that q squared is smaller than 4p. If q squared is smaller than 4p, look at here. Look at here. To be able to write this form, I used this inequality. If p to the power of 4 is smaller than 16q squared, when I multiply both sides of this equation by 16, can I get 16q squared is smaller than 64p? Yes, I can. By the same way, I can write here, if I square both sides of the inequality, q to the power of 4 is 16p squared. By the same method from this equation inequality, p squared is smaller than 4q. I can multiply both sides of the inequality by 16 and I will get q4 is smaller than 16p squared is smaller than 64q, and from the first one I got p to the power of 4 is smaller than 16q squared is smaller than 64p. From here, can I write, if I take the left and the right sides of the inequality, p to the power of 4 minus 64p is smaller than 0, and by the same method, didn't you like it? White and black? If you want, I can change it. Okay. So I change it for you. P to the power of 4 minus 64p is smaller than 0, and q to the power of 4 minus 64q is smaller than 0. How do we solve quadratic, or how do we solve these inequalities, guys? Remember, to be able to solve these inequalities, first we check zeros of the expressions, then we check the solution set by the help of sign chart. When I factorize it, the factors of p to the power of 4 minus 64p will be p and p cubed minus 64. And the factors of q to the power of 4 minus 64q will be q and q cubed minus 64. What makes the first one 0? If p is 0, it will be 0, or if p is 4, it will be 0. So here on the sign chart, I will have 0 and 4. I will have 0 and 4. We know that we know how to check the solution set by the help of sign chart. When we check for numbers greater than 4, they will be positive. So I started with plus, plus, minus, plus, and since it says the inequality is smaller than 0, if it's smaller than 0, I have to shade the negative part. So the solution set will be from 0 to 4. By the same way, if I check the solution set by the help of sign chart, the solution set for q will be from 0 to 4. And as you said, p and q, they are both between 0 and 4. And we know that p and q are, let's remember the question, p and q are different positive integers. So if p and q are different positive integers, assume that p is smaller than q. So what are possible ordered pairs for p and q? They are both smaller than 4 and greater than 0, which means that possibilities for p and q are 1, 2, 3. So what are possible ordered pairs if p is smaller than q? 1 and 2, 1 and 3, and 2 and 3 are possible ordered pairs for p and q. Okay, then I will check one by one. I will check the first one. If delta 1, I'm checking the first discriminant. If p and q are 1 and 2, if p and q is 1 and 2, I'm checking delta 1 and delta 2. Any problem with delta 1, 1 and 2? It will be smaller than 0 if I check delta 1 for 1 and 2. But delta 2 is going to be greater than 0, which makes a problem. Why? Because it says, the question says, for which ordered pairs p and q, the equation have no real solution. If delta is greater than 0, we'll have two real roots. Delta 1 or delta 2, they cannot be greater than 0. So from the first case, I got delta 2 is greater than 0. I failed. No solution from the first one. If p and q is 1 and 3, if p and q, the ordered pair is 1 and 3, when I check discriminants, again, no problem with the first one, but with the second one we have problem. It is greater than 0. It cannot be greater than 0. And for the third one, when I check p and q, 2, 3, this time, again, delta 2 will be greater than 0. Again, I failed, which means that for these ordered pairs, at least one of delta 1 or delta 2 will have real roots. So do we have any ordered pair p and q which makes our discriminant smaller than 0? No, we do not have. So there is no any ordered pair p and q which makes these two equations, which makes the discriminant of these two equations smaller than 0. So let's revise the problem. Some of you are late. This was the question. Equations were given: x squared plus px plus q and x squared plus qx plus p are 0. P and q are two different positive integers. For how many ordered pairs p and q? These equations have no real roots. First, we said that if the equations are x squared px plus q and x squared plus qx plus p are given, delta 1 will be p squared minus 4q, and delta 2, the discriminant of the equations, will be these two, p squared minus 4q and q squared minus 4p. In the question, it says that have no real roots. These equations will have no real roots, which means that delta 1 and delta 2, they are both smaller than 0. If they are both smaller than 0, p squared is smaller than 4q and q squared is smaller than 4p, which means that when I combine the inequalities, p to 4 is smaller than 16q squared is smaller than 64p, and q to 4 is smaller than 16p squared smaller than 64p. If I take only first and third, p to the power of 4 minus 64p will be smaller than 0, and q to 4 minus 64q will be smaller than 0. When I factorize them, the factors of these two inequalities will be p and p cubed minus 64 and q cubed minus 64. When I check the solutions by the help of sign chart, I got that p and q, they are both on the interval from 0 to 4. If p and q are integers from 0 to 4, we know that they have to be positive and different than each other. So we assume that p is smaller than q, and I have written the ordered pairs, possible ordered pairs. If p is 1, q can be 2 or 3. If p is 2, q can be 3. And then I checked 1, 2, 1, 3, and 2, 3, whether they make the discriminant smaller than 0 or not. When we check the first one, 1 and 2, the first ordered pair did not satisfy the second discriminant. Second discriminant is greater than 0. Is it possible? If it's greater than 0, there will be two real roots. It is not. We failed. In the second one, when I check 1 and 3, again delta 2 is greater than 0. We failed again. And for the third one, we failed again because 2 and 3, when you substitute them in the discriminant formulas, delta 2 will be greater than 0. So no real solution. So do we have any ordered pair p and q which makes our discriminants smaller than 0? No, we do not have. Any question, guys? Yeah, 0 pairs. Any question? No questions. So can I show you the next problem? Right. Next problem is from 2014 regional. It's a system problem. A system is given AB where A, B, C are real numbers. AB minus B is B plus 119. BC minus B is C plus 59. And CA minus C is equal to A plus 71. Find all values of the sum of A, B, C. Yes, let's solve this system problem. It's a regional question. I'm waiting for you to read, to start the question, to start to solve the problem. Try to change the equations a little bit. AB minus B, BC minus B, CA minus C. If you get something, please write here. Can you write left side of the first one? In the first question, Philip says there is a mistake in the first question. Philip, are you talking about this one, this question, and the first equation? $119. You think that AB minus A should be B minus 119. Let me check. I think no. It is like that. What you do to start to solve? Damian and Philip say that there is a problem with the first equation. Oh, yep. Thank you so much, Christina. It is AB minus A. Yes, guys. We do not change the right side of the first equation, but the left side is AB minus A. I'm sorry. It is my mistake. Thank you all, Christina, Damian, and Philip. Am I right? Yes, Philip, you were right. Can I start to solve it? Yes, we can factorize them all, but there is a trick while we are factorizing them. Let's start. From first equation, if I factorize it, I will get A times B minus 1. And on the right side of the equation, yeah, you're right, Philip. B minus 1 plus 120. Is it possible to write it in this form, 119? I have here on the right side. Can I write it as minus 1 and 120? Yes, why not? So if I factorize by this way, I can write A minus 1 times B minus 1 is 120 from the first equation. Let's say that this is A. And by the same method, from the second equation, we can get that B times C minus 1 is equal to C minus 1 plus 60, which is B minus 1 times C minus 1 is equal to 60. Let me name this as B From the second one I got B. And from the third one, by the same method, I got C times A minus 1 is equal to A minus 1 plus 72. Look, here it was 71. I've made it minus 1 plus 72. So it will be C minus 1 times A minus 1 is equal to 72. That is C. Now, I will use one of A and B or A and C or B and C. I chose, let me check what did I? Yeah, from A and B. I chose A and B. If we write A over B, what am I going to get? A minus 1 over B minus 1 and B minus 1 over C minus 1. If I write this, A minus 1 over C minus 1 is going to be 2. And from here, if I substitute this in C, the one I got in C, I will get that 2 times C minus 1 squared is equal to 72. And when I solve this quadratic problem, C minus 1 squared is 36 and C is negative 5 or positive 7. Any problem up until here? What did we do? We changed the equations A, B, C. We changed the equations given in the system. We got A, B, and C. A minus 1 times B minus 1 is 120, B minus 1, C minus 1, 60, and C minus 1, A minus 1 is 72. I chose A and B. If I use A and B, A minus 1 over C minus 1 is going to be 2. Then I substitute it in the third equation. In the third equation, in C, when I substitute C minus 1 to the power of 2 is equal to 36. So there are two values for C. C is negative 5 or C is 7. So I have to check all possibilities for C1 and C2. If C is negative 5, then A1, how do I find it? I will use this equation. If C is minus 5, when I substitute it, A1 is going to be negative 11. And when I go back, when I substitute, B1 is going to be negative 9. And the sum of A, B, C is going to be negative 25. And if C2 is 7, when you substitute them in the equation, C2 is 7, then A2 is going to be 13, and B2 is going to be 11, and the sum of variables in the second case will be 31. So we have two solutions. The sum of A, B, C is negative 25, or the sum of them is 31. Any question, guys? Do you have any question? Let me show you from the beginning. This was the system. AB minus, I have written B, but your friends corrected me. Thank you so much. AB minus A is B plus 119, BC minus B is C plus 59, CA minus C is A plus 71, and here is the solution. We changed the equations. I got A, B, C. A is A minus 1, B minus 120, B is B minus 1, C minus 1 is 60, C minus 1, A minus 1 is 72 is C. When you 99. Yep, prove it. How to prove it? If we check the left side of the equation, the first term is 1, and then I'll try to find the general term for this sum. 2 over 2 times 3 times 4. Look, 2, 3, 4, consecutive numbers. 2 over 5, 6, 7. So you see 2, 3, 4, 5, 6, 7, and so on until 2 over 1997, 1998, 1999. Is there any way to write each term as a sum of sum of some rational expressions. Do you have any idea about this problem? When you check the right side of the equation, 1 over 667, 1 over 668, you see, these are simpler rational expressions. Here I have 2 over 2 times 3 times 4. Is there any way to write it as a sum of any numerator over 2 plus any numerator over 3 plus any numerator over 4? For the third one, is it possible to write it as x over 5 plus y over 6 plus z over 7? I will try to factorize it then. Let me show it. Look at here. If n is greater than 2, can I write these expressions? If n is greater than 2, can I write the second one, the second rational expression in this form? 2 over n minus 1. If n is greater than 2, let's choose 3. Is it 2 over 2 times 3 times 4? Is it possible to write it each after the second term? Is it possible to write every single term in this form? 2 over n minus 1, n plus 1. You see, they're all consecutive numbers. So we can write them in this form. I'm supposed to find what over n minus 1. I'm trying to write it as a sum of a over n minus 1, b over n, and c over n plus 1. How to find a, b, and c here? How to find a, b, and c? When I have a common denominator, when I have a common denominator on the right side of the equation, the first numerator is going to be a times n plus 1 times n. And the second numerator is going to be b times n minus 1 times n plus 1, which is n squared minus 1. And the third one is going to be c times n minus 1, which is n squared minus n. Over n times n plus 1 times n minus 1. You see, the numerator is equal to 2 on the left side. So, I should make it a little bit. 2 is equal to what? A times n plus 1 times n, and b times n squared minus 1, and c times n minus 1 times n. Let me simplify it a little bit. From the first one I have 1n squared, a times n squared. From the second one I have b times n squared, and from the third one I have c times n squared. So we can write the equation in this form: n squared to the power times a plus b plus c. And how many n's do we have? I have a times n from the first one, and I have negative c times n from the third one. So n times a minus c. And at the end we have minus b. Look at here, guys. Do we have any term with n to the power of 2 or n on the left side of the equation? No. So that means the sum of a, b, c has to be 0, and the sum of a and c has to be 0, which means that a is equal to c from the second one. And since the only constant is negative b must be equal to 2, which means that b is minus 2. A and c are equal, and if a plus b plus c is equal to 0, then we can say that 2a is equal to 2, and a is equal to 1, and c is equal to 1. So the expression 2 over n minus 1 times n plus 1 can be written in the form of 1 over n minus 1 minus 2 over n, and plus 1 over n plus 1. The numerator is 1, the numerator is 1. Let me write here 1 plus 1 over something. Let me write the equation in this form, this expression in the second form. 1 over n minus 1, I didn't change it. Let me write here 1 over n and 1 over n plus 1 minus 3 over n. Can I do that? Opa. Can you see it, guys? I think no. I'm sorry. I haven't realized that you cannot see. Look. I have written the expression 1 over n minus 1 minus 2 over n plus 1 over n plus 1 in this form. I copied the first one. I have written the second one in the form of 1 over n minus 3 over n, and the third one I have copied. So the sum given on the left side of the equation, let me remind it, the sum 2 over 2 times 3 times 4, 2 over 5 times 6 times 7. The next will be 2 over 8 times 9 times 10. And the last one, 2 over 1997, 1998, 1999. How to write it by the help of this notation? 1, the first one I just copied. The second one, 2 over 2 times 3 times 4 can be written in the form of 1 over 2, 1 over 3, 1 over 4 minus 3 over 3. And the last one can be written in the form of 1 over 1997, 1 over 1998, 1 over 1999 minus 3 over 1998. Then what am I going to do? If I write all the terms in this sum, from the first term we have a 1, I have copied it. Then for the rest of the terms, I will copy only first 3 terms from each term given at the beginning. 1 over 2, 1 over 3, 1 over 4. Then the next will be 1 over 5, 1 over 6, 1 over 7, 1 over 8, 1 over 9, 1 over 10, blah, 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 1 over 666, 1 over 667, 1 over blah, 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 1 over, here, from the last one, what do we have? 1 over 1997, 1 over 1998, 1 over 1999. What about the fourth terms from each group? What about the fourth terms? Look at here, 3 over 3. From the first one I have minus 1. From the second one I will have minus 3 over 6, which is minus 1 over 2. From the next one I will have minus 3 over 9, which is minus 1 over 3, so on until minus 1 over 666. We will have the terms in this sum. So if you see, we have positive and again. When we group the terms from 1 to 1 over 666, you see, they are opposite, right? Minus 1 over 2, minus 1 over 3, blah, 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 minus 1 over 666. So can I cancel them? Can I dig them all? Yes, I can. So what left in this sum? What left? 1 over 667. 1 over 668, blah, 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 1 over 1998, 1 over 1999. This is the sum of the given expression on the left side. So did we prove it? Do we have the same on the right side of the equation? Yes, we do. 1 over 667, 1 over 668, blah, 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 1 over 1999. Any question? Any question? This was a nice question, I think. Here, maybe most of you can see this, how to write 2 over n minus 1 times n plus 1 in this form, but I wanted to explain it once again. After we write the expression 2 over n minus 1 times n plus 1 in this form, where is it? In this form, we have written the elements on the left side of the equation. 1 plus 1 over 2, 1 over 3, 1 over 4 minus 3 over 3. What will be the next term, guys? It will be 1 over 5 plus 1 over 6 plus 1 over 7 minus 3 over what? 6. And the next will be by the same method, 1 over n minus 1, 1 over n plus 1 minus 3 over n. When you apply this method to each term, you will get the sum of numbers from 1 to 1 over 1999. And if we take the fourth element from each group, we will have minus 1 over 2, minus 1 over 3, blah, 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 minus 1 over 666. Then you see, after you finish writing the terms on the left side, you will see that you have opposite terms, 1 and minus 1, 1 over 2, minus 1 over 2. Group them from 1 to 1 over 666. You can cancel them all. So we have left 1 over 667, 1 over blah, 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 1 over 1998, 1 over 1999 left, which is given on the right side of the equation. Any question, guys? Any questions? Is it clear? No reaction? You got the problem? Or what? Super, it's clear. If you're copying the solutions, I wanted to, if you copy them now, I wanted to show like step by step. Can I show a new problem? I think you understood and you started Muppet. So I am giving the new problem. Okay, system problem will be later. Yep. Radicals again. Find the sum of the roots of the equation square root of 2 minus x plus x squared and square root of 23 plus x minus x squared is equal to 7. Guys, we have solved harder ones. We have solved an equation, a similar one with cube. So I want all you to solve this problem. Right? If you understood the problem with cube roots, you can solve this problem. I'll be waiting for the solutions of this problem. The radicands are 2 minus x plus x to the power of 2 and 23 plus x minus x to the power of 2. In each radicand, second and third terms are opposite, right? In both radicands you have x to the power of 2 and x, so you can use a helping variable to solve this problem. Sandra, are you here? My students are not here. Sandra is here, so boys are not here, right? Dimitri is here as well. Okay. Is there anyone solved the problem? I told you this is much more easier than the previous problems. You're all able to solve it. Yes, Christina, Philip, Damian. Are you trying? Yeah. Heidi, Monica, Sandra, Dimitar. Who else? Blerta. Who else? Who else? Angela. I think the time is enough for this question. Let's start to solve it together. Okay, we are given a radical equation. When you are given this type of equations, the best way to solve them, you can take one of the radicals to the other side and square both sides of the equation, or you can square, in this form, you can square both sides of the equation, but it will be a little bit more complicated. So take one of the terms to the other side and square both sides of the equation. But before I do that, I can see that there are some, that you can do that, Christina, but I have a better way. Look, here we have 2 minus x plus x to the power of 2, and here we have 23 plus x minus x to the power of 2. So can I assume that the first radicand is equal to a, and the second radicand is equal to 25 minus a, or sorry, I forgot that I used t. The first radicand is t, and the second radicand is 25 minus t. Any problem if I write it? It will be simpler, right? Okay, then let's substitute the radicands and square both sides of the equation. The first one is root t plus square root of 25 minus t is equal to 7. Now, as I told you before, I will take one of the radicals to the other side. I chose t. Keep root 25 minus t on the left side, and take t, square root of t to the other side, and square both sides of the equation. What do we get if we square both sides of the equation? We will get 25 minus t is equal to 49 minus 14 square root of t plus t. If I simplify this expression, I will get 14 root t plus 24 plus root t, 7. If I divide both sides of the equation by 2, it will be 7 root t equals 12 plus t. So here, if I write it in quadratic form, it will be t minus 7 times square root of t plus 12. When you factorize it, the factors of this quadratic expression is going to be root t minus 3 times root t minus 4, which means that root t is going to be 3 and root t is going to be 4, which means that t is 9 or t is 16. Are we done? Did we solve the problem? I got t, but I'm supposed to find x. So let's go back. What was t? T is 2 minus x plus x to the power of 2. Let's substitute it now. If t is equal to 9, which means that x squared minus x plus 2 is equal to 9. The quadratic equation, simplest form of the quadratic equation is going to be x squared minus x minus 7 is 0. From here, if you check delta is greater than 0, you're asked the sum of the roots. So you do not have to solve it. Just tell me sum of the roots by the theorem. minus b over a, isn't it 1? Yes, it is. And then for the second t, if t is 16, x squared minus x plus t is 16, x squared minus x minus 14 is 0, delta is greater than 0, so the roots will be, sum of the roots, x3 plus x4 will be minus b over a, which is 1. So what will be the sum of the roots? x1 plus x2 plus x3 plus x4 is equal to 2. Understood? Any question? Christina got a1 is, which is a1? X squared minus x is 14. Yeah, we got the same. We got the same, Christina. I just saw it, I'm sorry. We got the same solutions. So let me show it from the beginning. Here is the question. I assume that the first radicand is t and the second radicand is 25 minus t. Then I have written the equation in terms of t. Root t plus root 25 minus t is equal to 7. We took square root of t to the other side and then squared both sides of the equation. We got 25 minus t is blah 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 blah. And then the simplest form of the quadratic equation is t minus 7 root t plus 12. If we factorize it, root t minus 3 times root t minus 4 is 0. That means t is 9 or t is 16. Now for these values of t, we solve the equations. If t is 9, if t is 16. If t is 9, sum of the roots is 1. If t is 16, sum of the roots is again 1. So the sum of the roots of the radical expression is going to be 2. I hope it is clear. Is it, guys? Who got it? Who got it? I can see Christina solved the problem. Ariane, Monica. Dimitar, Sandra. Who else? Angela, Philip. Okay, if it's clear, I can show you the next problem, right? Damian didn't solve it. Why not? It is clear. Okay. Okay, let's see the next problem. Is a system problem again. Last year regional problem. Solve the system in the set of real numbers. 1 over x plus 1 over y plus z is 1 over 3. 1 over y plus 1 over x plus z is 1 over 5. 1 over z plus 1 over x plus y is equal to 1 over 7. Solve the system in the set of real numbers. As I remember, this question was in Sigma and they asked it last year in regional. Yes, try to change the equations a little bit. Try to write them in some other forms which is easier to solve. 1 over x plus 1 over y plus z, 1 over y plus 1 over x plus z, 1 over z plus 1 over x plus y. How is it going? What's the hint for this problem? You can try to get a common denominator on the left side and then cross multiply. Cross multiplication. After you do cross multiplication, you will get simpler equations in the system. I mean, for the first one, multiply the first rational by y plus z and the second rational by x. After you get a single rational expression on the left side, cross multiplication. Guys, may I start to solve it? Okay. Let's see what to do for the first equation. I told you you should get a common denominator, then multiply them. From the first one, if I do the steps that I told you, if I apply the steps I have mentioned, I will get xy plus xz is equal to 3 times x plus y plus z from the first one. From the second one, I will get yz plus yx is equal to 5 times x plus y plus z. And from the third one, I will get xz plus zy equals 7 times x times y times z is equal to, is from the third one. And before that, I have written that x, y, z cannot be 0. Why? How? To show it, okay. Let's show it. Let me change my pen. In the first, I think it's enough to show at least one. The first one, let me multiply 1 over x by y plus z. So I will get y plus z over xy plus xz. And the second one, the second rational expression will be multiplied by x. Both will be multiplied by x. So I will get x over xy plus xz is equal to 1 over 3. And from here, Do we have a common denominator? So can I write it as a single rational expression? Is it going to be x plus y plus z over x y plus x z is equal to 1 over 3? And can I do cross multiplication here? Is it going to be 3 times x plus y plus z is equal to xy plus x z, which is the first one. Whose question was this? Yeah. Did you understand the first one? Do you want me to solve all the others by the same way how I got 2 and 3? Do you want me to show them? Okay. So xy plus xz is 3 times x plus y plus z. Yz plus yx is 5 times the sum. And xz plus zy is 7 times the sum. How can I work with the new system now? The system turned into this, right? So can I write the equality from the third one? A over c. Y over z is 1 over 5. From all this, we can write that 5y is equal to z is equal to 9 times x. Now, any problem up until here? Let me show it once again. I have changed the system a little bit. I got this form. X plus y, xy plus xz is 3 times the sum. Yz plus yx is 5 times the sum. Xz plus zy is 7 times the sum. Then I add first and second, subtract the third one, I got a. Second plus third minus first gives me b. First plus third minus second gives me c. And if I use a and b, a over b is x over z, which is 1 over 9, which means that z is 9x. And if b over c is, if I check b over c, it is y over x. Y over x is 9 over 5, which means that 5y is 9x. And a over c is y over z, which is 1 over 5. So 5y is equal to z is equal to 9x. Any problem up until here? Damian? Is it clear? If it is clear, in A, I will substitute that. I will substitute in A, look at A, where is A? With the connection, there is a problem, huh? Okay. Remember A is 2 times x times y is equal to x plus y plus z. It looks the simplest one, so I chose A. I will substitute z into, I will write x and y in this equation in terms of z. So z is 9x, or x is equal to z over 9. 5y is equal to 9x, or x is equal to 5y over 9. I'm sorry guys, I have mixed it here. Z is equal to 5y, or z is equal to 9x, which means that y is z over 5, or x is z over 9. If I substitute them here, you see x is z over 9, y is z over 5, equals x plus y plus z. So z over 9 plus z over 5 plus z. When I simplify this equation, it will be 2z squared minus 59 is z is equal to 0. From here, if I factorize it, z times 2z minus 59 is equal to 0, and z is 0 or z is 59 over 2. There are two options for z. Can z be 0, guys? Remember the note I have written at the beginning. Z cannot be 0 because 1 over x, 1 over y, 1 over z. Look, how can 1 over z be 0? Z cannot be 0. So we eliminate the first root. Z is equal to what? Z is equal to 59 over 2. We know how to write x and y in terms of z. So if you substitute z in the other equations, you will get that x is equal to 59 over 18 and y is equal to 59 over 10. Christina, did it stop again? Can you hear me? It's okay now. Okay, super. Is the solution clear, guys? I will show it from the beginning, so you will be able to write it. Okay. I think the time was enough to copy it down to understand it. Let's see the next problem. Solve the equation in the set of real numbers. What is the equation? Let's read it together. 18x to the power of 4 plus 8 minus 63x cubed minus 42x plus 79x to the power of 2 is equal to 0. What a nice one. Yep, solve it. Solve it in the set of real numbers. How to solve it? As we see, this is not a quadratic equation. Somehow we can reduce it to a quadratic equation by grouping terms. Try to solve it a little bit. Try to group the terms. Try to reduce it at least to a quadratic equation. Then I will solve it. I will start to solve it. How is it going? How did you group them? The left side of the equation looks really complicated, right? Let's see how to group them together. When we group first by second, third by fourth, and the fifth term is alone, it will be 18x to the power of 4 plus 8, 64x cubed plus 42x plus 79x to the power of 2. Look at the same. Guys, can you hear me? It says connection. Wait. Can you hear me now? Did it stop? Okay. You cannot see the video. Since when? Can you see it now? Okay, sorry. Okay, now I grouped first by second, third by fourth, and the fifth is alone. So when I take the common factors out of the brackets, from the first one I have 2. Both are divisible by 2, so I can write the first group 2 times 9x to the power of 4 plus 4. And the second one is negative 21x times 3x to the power of 2 plus 2. And the last one is 79x to the power of 2. You guys, when I check first and second terms, look at here. 9x to the power of 4, 3x to the power of 2. 4, 2. Square of the first term here. Square of the second term here. So I will do something with these two. But later, because we have a bigger problem. 79x to the power of 2. Can I divide the whole equation by x to the power of 2? Can I do that? I can, but before I do that, I need to check whether 0 is a solution of the problem or not. I have checked it and 0 is not a solution of the problem, so we can divide every single term in this equation by x to the power of 2. And when I divide them by x to the power of 2, I get that 2 9x squared plus 4 over x to the power of 2 minus 21 times 3x plus 2 over x plus 79 is equal to 0. Now, I can use a helping variable, right? It looks much better now. How am I going to write it? Here in this part, I want to make something. Look, if I assume that 3x plus 2 over x is equal to t, what will be the square of this? It will be 9x to the power of 2 plus 4 over x to the power of 2 plus 12 is t squared. Look, did I get this in terms of t squared? Yes. So can I write 9x squared over 4 over x squared is equal to t squared minus 12? Yes, I can write it in that form. So 9x squared plus 4 over x squared is equal to t squared minus 12. I will substitute it in the equation. Here I show you. 2 times t squared minus 12 minus 21 times t plus 79 is equal to 0. Let me simplify this quadratic. We will get 2t squared minus 21t plus 55 is 0. I factorized it. If you want, you can use quadratic formula to solve the problem. When you factorize it, it will be 2t minus 5 times t minus 11 gives you negative 21t. So 2t minus 11 and t minus 5 is equal to 0, which means that t is 11 over 2 or t is 5. Okay, now I will solve the problem for t. I solved the problem for t. Now I have to solve the problem for x. If t is 11 over 2, then 3x plus 2 over x, which was t, is equal to 11 over 2. When you write it in quadratic form, you will get 6x squared minus 11x plus 4 is 0, which gives you 3x minus 4, and 2x minus 1 is 0. From here, the roots are 4 over 3 and 1 over 2. And from the second case, if t is equal to 5, then 3x plus 2 over x is equal to 5. Here, if you factorize this quadratic equation, you will have 3x minus 2 times x minus 1 is equal to 0. From here, the roots are 2 over 3 and 1. So what are the solutions of the problem? Let's remember the problem here. The solutions of the equation, this higher degree equation, are 4 over 3, 1 over 2, 2 over 3, and 1. Any problem? Any problem? Is the question clear, guys? No? Please say it didn't stop again. Super. It's clear for Damian. What about the others? Okay, I'll go down. Lerta Angela. Monica. Damian, have you copied the first part? You asked for 2 minutes. Have you copied this part? Okay. Christina, have you finished? Christina, you were copying. Have you finished? Okay, guys, can I change the question? We have like 10 more minutes left. Okay, I will. Another republic problem. Solve the equation in the set of real numbers. 2x squared minus 3x is equal to 2x times square root of x squared minus 3x plus 1 is the equation. Solve it in the set of real numbers. I think it's too simple for a republic. But the republic. It is too simple. How to solve? I think all you can see that we have common terms on the left and on the right sides. X squared minus 3x. If you write it as x squared plus x squared minus 3x, you will have common terms. Then you will use a helping variable, t whatever you want. Then solve it by the quadratic way. Let me show you the first part. Write the given equation in this form. X squared plus x squared minus 3x is equal to 2x times x squared minus 3x plus 1. Now you can assume x squared minus 3x. Since on the right side it is under the radical sign, better to give a variable like t squared, y squared, whatever. I used y. So if x squared minus 3x is equal to y squared, substitute it in the equation and try to solve the problem, guys. How is it the square root of, sorry, I couldn't read it, square root of x squared minus, no, x to the power of 2. This is my 2. It is 2. X squared minus 3x. You're welcome. I stopped because I think you can continue from here if you know the equation is x squared plus y squared is equal to 2xy plus 1. Let's continue together. We have no time and I have prepared 16 questions for today. I will substitute this in the equation x squared minus 3x is equal to y squared. Then the equation, the first one, it turns into this form. X squared plus y squared is equal to 2xy plus 1. So if we take 2xy to the left side, we will get perfect square of x minus y. If x minus y is equal to plus or minus 1, right? It has two solutions, positive or negative 1. Then we can write this x is equal to plus or minus, y is equal to x plus or minus 1. So first I assume that y is equal to x minus 1. If y is equal to x minus 1, I go back, I substitute the values in this equation. If x minus 1 squared is equal to the square root of x squared minus 3x squared, when you solve this problem, you will get the quadratic x squared minus 2x plus 1, which is x squared minus 3x on the other side here. When you square y, you get this, and x squared minus 3x is from the left side. I just changed the sides. When you solve this quadratic problem, x is equal to minus 1. Remember, when you have radical expressions, after you find the roots, you need to check whether it satisfies the equation or not. When I substitute minus 1, the radicand is going to be a negative expression which cannot be possible. It is not possible for a square root, so we do not have a solution from the first case. From the second case, if y is equal to x plus 1, then we write the equation again. X plus 1 squared is equal to square root of x squared minus 3x to the power of 2. Square both sides, x squared 2x plus 1, x squared minus 3x. When you write it in quadratic form, digitic, 5x is minus 1, x is equal to minus 1 over 5. Does this satisfy the equation minus 1 over 5? Yes, it does. So how many solutions do we have for the problem? There is only one solution, which is minus 1 over 5. Here is the question. I hope it is clear. And I will show the steps. Once again, here is the question. First, we have assumed that x squared minus 3x is equal to y squared. Then I have written the equation in this form: x squared plus y squared is equal to 2xy plus 1. If you take 2xy to the left, you will get the perfect square of x minus y. If x minus y squared is 1, so then x minus y is plus or minus 1. Or it can be written in the form of y equals x plus or minus 1. So you check both cases. If y is x plus 1, or if y is x minus 1. When you solve these equations, from the first case, if y is x minus 1, you will not get any solution. There won't be a solution. I mean, we got the solution, but it did not satisfy the equation, so we failed. From the second case, if y is equal to x plus 1, we got this equation, the x squared by x squared, 5x is minus 1, x is minus 1 over 5. When you substitute minus 1 over 5 in the equation, it satisfies the equation. So there is only one solution, which is negative 1 over 5. Questions? Do you have any question? Is everything clear about the 15th problem? No question? Clear? Okay, I can show you the next problem then. Can I? Okay. Let's see the last problem for today. The last one, guys. It is a regional problem again. 2 years ago in regional. Solve the irrational equation. Square root of x squared plus x plus 6, square root of x squared minus x minus 4, square root of x squared plus x plus 6 minus square root of x squared minus x minus 4 is equal to 5. Solve it. If you try to square both sides of the equation in this form, you will fail, guys. You will have a really complicated expression. Look at here. You have x squared plus x plus 6, x squared plus x plus 6. As you see, the numerator and denominator, they are conjugates, right? A plus b, a minus b. So better first cross multiplication. After that, yes, we have it. After that, after you do cross multiplication, you can solve the problem easily. You have 1 minute. Then I will explain the solution. Then we will be done for today. For quadratics, we will be done. Guys, did you get something? Problem was asked in regional, but it is really simple. Okay. Cross multiplication, x squared plus x plus 6 plus square root of x squared minus x minus 4 is equal to 5 times square root of x squared plus x plus 6 minus 5 times square root of x squared minus x minus. After I write this, I will take the common terms to the same side. Here I have x squared minus x minus 4. When I take this negative 5 times this to the other side and x squared plus x plus 6 to the right side, I will get 6 times root x squared minus x minus 4 equals 4 times x root x squared plus x plus 6. So we can simplify 6 and 4 both by 2. We will get 3 times root x squared minus x minus 4 to the power of 2 and 2 times square root of x squared plus x plus 6 to the power of 2. After that, we square both sides of the equation. If we square both sides, we will get 9 times x squared minus x minus 4 and 4 times x squared plus x plus 6. Now we multiply each term on the left side by 9. We multiply each term by 4 on the right side, and then we will get this. 9x squared minus 9x minus 36 is equal to 4x squared plus 4x plus 24. Now we take them all to the same side. 5x squared minus 13x minus 60. And by quadratic formula, 13 plus or minus 169 plus 1200. By the way, I got this by calculator. 169 plus 1200 gives us 37. 13 plus or minus 37 over 10 are the solutions of the problem. If you solve it with plus, it will be 5. If you solve it with minus, it will be negative 12 over 5. Opa, you cannot see. From the beginning, let me show it once again. Then I will finish the Okay guys, thanks for the attention. See you tomorrow at 9. I hope it was helpful. The questions were nice and they were clear. Okay. See you tomorrow. Bye bye. You're welcome. You're welcome.